I welcome all the students to Pune College of Arts, Science and Commerce, Camp Pune 1. I teach statistics at FYBSc and FYBA level. The topic subject title is discrete probability and discrete probability distributions. Myself, I am Dr. M.B. Pathan. In last lecture, we tried to understand Bayes' theorem by solving some numerical problems. In today's class, we'll try to start a new chapter under the heading of univariate probability distribution. This is a third chapter as per your syllabus. To study probability distribution, we add the concept of variable. What I taught till chapter number 2, we understand the concept of probability by using sample space and events. In today's class, we can understand the concept of probability by defining a variable. Before going ahead, I will explain the concept of univariate. If I split the word univariate, the meaning is one variable. Uni means one. So study of probability with the help of one variable may be considered as univariate probability distribution. Definition number 1 is random variable. It is abbreviated as R.V. I define random variable as a real valued function defined on sample space to the subset of real numbers is known as random variable. It is not a new concept to you people, because when students studying science with a group, he or she always opt mathematics subject in 11th and 12th. Ultimately, all of you has knowledge of function. Function is nothing but a relation between two sets. Let us say set A and set B. So any relation defined on set A, then you get another set as an image. So that relation is known as a function. So we are taking a help of this knowledge of function to define a random variable. So random variable is nothing but a function. And according to mathematics, function is a relation. So I define random variable as a relation between sample space and subset of real numbers. So any relation by which element of sample space transfer to the real values, that relation is called as a random variable. Just recall your knowledge of mathematics. Usually in mathematics, function denoted by small f, colon, capital A, arrow, capital B. Capital A is called as a domain. Capital B is called as a codomain, sometimes called as a range set. Now you have to make a small difference in your knowledge. In place of capital A, if you write omega, that will be domain for random variable. After defining a relation on domain sample space, you get another set as a B. And what is B here? B is a subset of real numbers. So it is very simple concept if you take the knowledge from mathematics of function. So any relation defined from sample space to the set of real numbers is known as a random variable. It can be denoted by any capital letters. Capital U, capital V, capital W, capital X, capital Y, capital Z, etc. So whenever you want to write a random variable, you have to use capital alphabet. Commonly, we write capital X as a random variable. So as per definition of mathematics, I write random variable. It should be capital X, make a correction. Capital X colon omega goes to set of real numbers. So you can see now this is exactly definition of function in mathematics. Where is the difference come? In mathematics, capital A keep on changing as per your problem under study. But in statistics, your capital A, that is a domain, always fixed, and that is a omega. So if you define a function on omega to the subset of real numbers, that function is called random variable. I think everybody understands the concept of random variable. After having a random variable, we define discrete random variable. A random variable taking either finite or countably infinite values is known as discrete random variable. So discrete random variable is depend on concept of random variable. So in a codomain, in the range set, if you get a finite collection of values or sometimes countably infinite values, then corresponding random variable is labeled as a discrete. Dictionary meaning of discrete is a separate collection. So random variable having finite or countably infinite values known as a discrete random variable. If capital X is a discrete random variable, then the collection of values taken by capital X is known as a range set. That means what values you get from real numbers, that collection is called range set, and that is from the concept of mathematics. I write the collection as small x1, small x2, small x3, dash dash small xn. I will stop here if it is a finite collection. I will continue further if the collection is infinite. So we have two possible range set. It may be finite, it may be infinite. To understand the concept of discrete random variable, I put some simple examples. Example 1, number of children in a family is discrete random variable with range set. So if you take a survey and if you try to make a record of how many children in the family, so possible values you will get 0. There may be family having no child. It may be 1, it may be 2, and continue with some finite number small n. So this is nothing but range set, and what I wrote, number of children in a family. This is called as discrete random variable. Example number 2, the number of accident occurs on a certain square of a highway is discrete random variable with range set. Collection curly bracket always, not parenthesis, not square bracket. Collection always by curly bracket. Maybe 0 value, no accident, 1 accident, 2, 3, and so on. Here I will not put upper bound because we don't know what will be the maximum accident recorded. So that is open in the upper side. So this is the example of countably infinite values, but separate collection, not interval. So if you have separate collection, not interval, it labeled as discrete random variable. Now we have third definition, probability mass function, abbreviated as PMF. A function, capital P. All of you keep in mind, whenever I say function, student has impression as an equation form. That is not a concept of function. Function is a relation. Function is a correspondence. Every time if we say function, student recall immediately y equal to x square, y equal to sin x. This is a function in mathematical form. But what is the true concept of function? It is a relation between two sets. It is a correspondence between two sets. So I have a function P, that means I have a relation which is defined on each value of discrete random variable x. That means I define capital P on x1, similarly x2, and so on. How I define? There is a condition. Condition number 1, your function on each value of capital X takes non-negative value. Non-negative means 0 included. So function defined on each value of x is either 0 or greater than 0. It is true for all. This is the symbol of for all. I went to n, you can continue also. Second condition is important to have PMF. Summation I1 to n. Here P is missing. You should write P. P probability, P means probability of xi total should be 1. Everybody should make correction here. Summation I1 to n, probability of xi should be 1. You can recall the topic from previous chapter, which is exactly parallel to this. And the name of topic is probability model. So this definition exactly parallel to probability model. Where is the difference? Difference is on domain. Probability model define on sample space. And that is why here I put a condition PWI greater than equal to 0, summation PWI equal to 1. And if these two conditions satisfied, corresponding function is known as probability model. We have seen the examples based on probability model also. Now probability mass function, again we have a P, but it is defined on each value of X. So sample space omega replaced by capital X. Just like W is an element of omega, so we put W here. If you want to define PMF, replace WIXI in probability model. You will get the definition of probability mass function. This is your first definition. Then P is known as PMF. I take one more definition. Then with the help of these 4 definitions, we'll see the numerical. I will explain all these 4 definitions with suitable example to clear each and every doubt. Fourth definition is probability distribution. The ordered pair values of discrete random variable x with respective probabilities is known as probability distribution. So under definition number 4, what we do? We make ordered pair values of variable x with respective probabilities. That ordered pair collection is known as probability distribution. It can be denoted as curly bracket xi comma pi semicolon I1 to n. You can recall paper 1 frequency distribution. The word frequency replaced by probability. In frequency distribution, how you write a table? Xi with repetition Fi, X2 with repetition F2. So the same concept of frequency distribution written in terms of probability distribution. So I have tabular representation of probability distribution. Capital X, put the vertical line here. X taking values x1, x2, at the center xi, general case, dash dash xn. Px, the probability assigned for every value of x under PMF. X1 replace, X1 has a chance P1. X2 has a chance P2. Xi has a chance Pi, and so on. If I make a total of probabilities as per definition of PMF, total of probabilities should be 1. and that is the reason I write total as 1. So this is nothing but probability distribution of random variable x. So today I had given you totally 4 concepts under the heading of univariate probability distribution. All these 4 concepts I will explain with one numerical example, not today, in next lecture. But what is the example? I will explain little bit. A fair coin is tossed 3 times. Obtain the probability distribution of getting number of heads. Now you can recall exactly same problem I took in previous chapter. So why this is again repeated here? The answer of this question you will get when I will solve this numerical example by this chapter. Otherwise, you have an answer of this question in your notes from previous class. A fair coin is tossed 3 times. So I can write omega with 8 element, and by using that omega, I can find the probability of this. But what is the purpose of taking this example? That I will explain when I will solve this numerically in next lecture. Before closing, I will revise today what I taught you. At the beginning, I said univariate is nothing but study of one variable. Then I define a random variable with the help of mathematics knowledge. Random variable is nothing but function, and function is nothing but relation, nothing but correspondence. Many times student has misconcept function is always in the equation form. It may in the equation form, it may not be in the equation form. But basic idea of function is nothing but relation, is a correspondence. So any relation defined on sample space to the subset of real values is known as random variable. By using a random variable, we go for discrete random variable. If the random variable taking finite or countably infinite values, then corresponding random variable is known as discrete random variable. After having a discrete random variable, we define probability mass function, PMF. This concept goes exactly parallel to the concept of probability model, what we studied in previous chapter. In probability model, just replace Wi, which indicates sample point, as small xi. You will get definition of PMF. Probability model defined on the sample space, whereas probability mass function defined on the random variable capital X, which takes separate values x1, x2, dash, dash. So I define a relation, I define a function on each value of x such that each value is non-negative and total of values should be compulsory 1. After having discrete random variable and probability mass function, I prepare a table. So I put values of variable, values of probability mass function in a table form. That table is called as a probability distribution. You can see the screen, x taking value x1 with chance p1, x taking value x2 with chance p2. So this entire table is known as probability distribution of random variable x. Today I will stop at this stage. Remaining part in next lecture.